Okay, so I'm recording here. So now, last day, if you weren't in class, you would have missed this, and this could be, I guess, a little challenging if you, weren't here. But for any of the students that were here, we only have one slide left, and that slide is, sorry, a lot of clicking, right here. So to get you guys kind of warmed up or started off today, I would like for you guys to try these questions. I don't think we did this yesterday, or I don't think we had time anyways. So give these a try, and we'll check your answers, and then we have officially finished chapter 4. And just a reminder that your test on Thursday is only chapters 3 and 4. It's not anything from chapter 5. So I will be back in 2 minutes, or maybe 3 minutes. This might take you a little extra time, but I would love for you guys to try these, and we'll be back in, let's say, thank you for reminding me to record. So there are workings here that you can show, but you don't actually need to. But first thing you would want to do is to figure out how many ions this chemical is getting split into. So there's this one, and then there's the second one. Now, the second one, be very careful, because I'll show you something in a minute. I'm writing a little small here, but it's actually working out. With the second one, it's really important that you note that there are 2 silver ions in that, because there's 2 right here. So when I write my K expressions, K for the first one, or KSP, becomes the concentration of zinc times the concentration of sulfur. Okay, and the KSP for the second one becomes the concentration of silver squared times the concentration of sulfate. Now, all this is fine, it's easy, but we're not done the question yet. I need to solve for my compounds, or my concentrations. So what I do is I let these equal X. So this is basically math now, not chemistry. We finished the math part, the chemistry part of this. We've come up with the KSP equation. All I need to do now is solve for X. So let's do that. And this is literally all you would see on a test, by the way. I think somebody asked the other day, it might have been maybe Yasmin, if you would see like 4 or 5 or 6, and no, you would only see 2 or 3. So this becomes 3.0 times 10 to the 23 equals X times X, or what we would call X squared. And the bottom one becomes 1.4 times 10 to the minus 5. And this is the only one that gets a little hard. It's equal to X cubed. So finally, X is the square root. I'm writing too much here. I'm going to run out of room. Maybe not. But X would be the square root of 3 times 10 to the 23. Let me do this on my calculator here. So I get for my first one 5.5 times 10 to the minus 12. And for the bottom one, it would be the cube root of this number. You guys are all in calculus, or some of you are anyways, so this is nothing for you guys. So let me do this one. I don't really know where my, oh, yes, I do. I was going to say, I don't know where my cube root button is, so I've been doing this another way, but it's all good. I just found it. I got a new calculator. Okay, so for the top one, I get 0.11 moles per liter. All right, there we go. That's the answers to both of these. Sorry. So yeah, I got some questions in the chat here. I'll talk about the test in a minute. Harold asks, why is the second item cubed? The second item is cubed because, let me get a different color here. I have 3 ions. I have 2 silver ions and 1 sulfate ion. So that means there's 3 X's. Somebody was just chatting in the voice chat. Did you have a question?
Yes, sir.
Yeah.
Sir, we will not calculate the AG as 2s power 2. It will be like 4.
No, there's only 3. So this AG, there's 2 here. If you can see where I'm writing in the orange on the bottom here, there's 2 AGs and there's 1 sulfate, SO4. So 2 plus 1 is 3. There's not 4. There's only 3 things.
Okay.
Yeah.
Okay.
Perfect. All right. Oh yeah, 1. Well, oh, hold up. Yeah, Iman mentions I might have a mistake in my, whoops, in my calculation here. When I put this in on my calculator, I'm going to fix this. When I put this in on my calculator, guys, I put in times 10 to the negative 3. I didn't put in times 10 to the negative 5. So let me go fix that. I think Aman is correct. So 1.4 times 10 to the minus 5, the cube root of that, sorry about that. That was a typo on my part. It's 0.24. The cube root, not the square root, the cube root. All right, I just fixed it there. Cool. All right. Any questions on that?
Sir, because in worksheet answers is different, like, I don't know. It's different. I don't know how. They calculate this one as 2s power 2 and other one as 1. So it will be square root over 4, like, or 4 multiply 1, something like that. I do not understand.
Yeah, that might be.
They will multiply the KSP by 4 and they will put it in the square root.
That might be, that's in the worksheet you said?
Yeah.
Yeah, that might be a different question. This is not the question that's being asked here. So in the worksheet, okay, it might be a different question.
Okay, sir.
Perfect. Okay, cool. So, whoops, I can just open up the worksheet here and just double check. Give me 1 second here. I'll open up the answer key. Yeah, no, this is like what I'm seeing on the worksheet is pretty much how we're doing it. There is one exception for that. And it's some of the harder ones. There's a few hints for questions number 4 and 5, for example. But no, we're good. All right, so now Iman in the chat asked a few questions. Let me get into that. Oops, sorry, didn't mean to do that. Aman in the chat mentions how many multiple choice. There's 10. How many long or short answer questions? I think there's about 6 of them. So it's basically the same as your first test. Just the only difference is, of course, it's on chapters 3 and 4 and not on chapters 1 and 2. So there'll be 10 multiple choice and 6 long answers or so. All right. Oops, I didn't mean to do that. So It's 3:53. I'm just going to introduce chapter 5 to you guys. And like I mentioned, we will do a review for your test tomorrow evening. I'll send out a link to YouTube. And if you can't make it tomorrow evening, you can just watch the recording before your test. But I do, unfortunately, because we're running low on time, I do need to start chapter 5 today. So chapter 5 is about, it's called electrochemistry. So let me share my slides here. Chapter 5 is on electrochemistry, and I'll only just kind of introduce this today. I won't get into too much of the complexities of the topic. There's a question from Iman. It says the equation for the high time is not in the data booklet. I don't know what the high time is. So if you could clarify your question, Iman. I've never heard of high time. Okay, so chapter 5. Chapter 5 is on electrochemistry. Now think about what we did in chapter 2, where you guys, it was called thermochemistry. So that was about the chemistry of thermochemical reactions or heat-based reactions. Well, this chapter is called electrochemistry. So this chapter is about the chemistry of electrochemical reactions, or like electricity. So we're going to be looking at the flow of electrons. All right, sorry, just reading the chat here. Abdul Halim, thank you for that. It's half-life is what you mean. The half-life is in your data booklet. I don't have a data booklet with me, but it's not in the general equations section. It would be in another section in your data booklet, but it is there. Okay, so let's see. It's 3:55. How far do I want to go today? I don't want to do too much because I know you guys got a test this week. Sorry, I'm just clicking ahead. Okay, I'm definitely not going to get into this today. So if you guys can let me get to maybe one, 2, 3 slides, and that'll be it for today. All right, so balancing redox reactions. This is the first thing you guys need to know when you're dealing with electrochemistry. Now you guys might not remember this from chemistry 1120, and that's okay. It's called a redox reaction. It's actually the combination of two words, reduction and oxidation. And this is very wink, 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 wink important for your final exam. Sorry, I'm having the same problem here where I can't draw on my slide, so I'll have to do it this way. Huge wink face here. You definitely need to know these definitions for your final. Obviously, this is not on your test on Thursday. Reduction is when the oxidation number, which is a fancy word for charge, of your chemical decreases. So what reduction is when electrons are actually gained. And I know that sounds confusing. You're thinking, electrons gained, why do they call it reduction? Well, the name comes from the fact that your charge, the oxidation number, which is again is fancy chemistry term for charge, goes down, it decreases. Oxidation is when a chemical has its oxidation number increased, and that means electrons are lost. So your charge would go up. Now, I have an easy way for you guys to remember this. And actually, if you just give me 1 second here, I'm going to close this PowerPoint, and I'm going to try to open it again. Just give me 1 second. Oh, I want it so I can write on it. And as you guys know, sometimes the computer doesn't let me do that. So just give me 1 second and I'll open this up again. All right, let's see if this works. Ah, perfect. Okay, cool. So I want to show you something that you might have learned in chemistry 1120 with me, or you might have had Michelle. A good way to remember what a redox reaction is an acronym called oil rig. This is, you definitely, you want to take a picture of this or write this down. O means oxidation, is loss of electrons. Reduction means, or rig means reduction is, wow, why is this always happening on the white? This is something to do with the white screen too, really makes this mess up. But anyways, is gain of electrons. So to summarize these things, oxidation is loss of electrons. That means your charge goes up. Reduction is gain of electrons. That means your charge goes down. Again, I know that can be confusing because you're thinking, reduction. Why is it gaining electrons? Well, what's happening is when the chemical gains electrons, the charge decreases. So this is how batteries work. This is how your cell phone is working right now. This is how, your remote control for your air conditioner or your television work. Inside the battery of your cell phone or remote, there's two chemicals. One is being oxidized, meaning it's losing electrons. One chemical is being reduced, meaning it's gaining electrons. And as the electrons travel from one chemical to another, your cell phone or your remote control is absorbing them. Absorbing is the wrong word, but it's kind of like interacting with these electrons as they move. And that's what powers your cell phone or remote control or anything, like even your car or your vehicle, anything with a battery. One chemical is oxidized, which means it throws electrons away. Another chemical is reduced, which means it's gaining or pulling in these electrons. And whatever you stick in the middle of this, whether it's a cell phone or a car, it's absorbing or reacting with these electrons. And that's how we get power from batteries. It's actually pretty amazing. All right, let me just open the chat there. I got 2 messages. Oh yeah, thanks, Harold. Yeah, definitely me versus my PC sometimes. As like some of my students from last semester would know, my pen used to be a lot worse. I've got it fixed a little bit. Okay. Now, I know you guys got your test on Thursday, so I'm not going to get too deep into this, but I'm going to warn you that what I'm going to do on Sunday's class is a little bit complicated. The other class, because they're ahead of me, they're actually doing this on their test. We're not going to bother doing it on our test. We'll just do chapters 3 and 4. But this next topic is actually on the other class's test. I think they're writing their test tomorrow. Luckily, today I'm just going to introduce it, but I will warn you on Sunday, it is something I'm going to cover, and it's definitely a little bit complicated. So one hint or one step you can do to kind of wrap your head around an oxidation and reduction reaction is to write them into half reactions and balance the charges with electrons. And again, I'm not going to get too much into this today. You can actually kind of ignore me for the next 5 minutes if you want, because I don't want to confuse you or anything before your test, but this is definitely something we're going to deal with on Sunday. Splitting these reactions in half and balancing with electrons. So look at the reaction above. We have sodium ion plus potassium. Keep in mind or really look at the charges. Notice that it's sodium ion and it's potassium metal, no charge, turns into potassium ion and sodium with no charge. So something is happening here with these chemicals and with their charges. This is a prime example of a single replacement reaction like you did in chemistry 1120 with me or Miss Michelle. Anyways, step number one, if I want to figure out which chemical is being oxidized and which chemical is being reduced, I can split them in half. So something's happening here. The sodium plus is turning into sodium metal, and the potassium metal is turning into potassium plus. So what I'm going to do is I'm going to see where electrons fit into this situation. I'm going to balance the charges with electrons. Now remember, one electron is one negative thing. I'm just going to say one electron is one negative. So why am I adding an electron on the left over here? Well, think about it. One negative electron cancels out with the one positive charge on this. So if I look at my overall charge, and again, we're going to talk more about this on Sunday, but if I talked about my overall charge on the left, it would be 0, and the overall charge on the right would also be 0. Same thing for the potassium. My one electron cancels with my one positive. So my overall charge on my left is 0, and my overall charge on the right is 0. Again, don't let this stress you out today, because you guys tonight and tomorrow, you want to be worrying more about your chapters 3 and 4. So kind of put this in the back of your head until Sunday. And the last thing I want to show you is this example here. It says write the oxidation and reduction half reactions for these below. So let me do this, and then halas, we will be finished. And let me just check the chat as well. Yeah, so Abdul Halim, well, two things. Iman, this is definitely wink wink for your final, not for your test, don't worry. And Abdul Halim, yeah, that's right. When you split them, the side with the charge, the side with the more positive charges takes the electrons. That's right. That's a good way to think of it. So let's just do, maybe we'll just do one of these. And I'm going to ask you guys maybe, while you're waiting for me on Sunday afternoon to try this on Sunday. Don't do this now. Again, I cannot stress this enough tonight. Don't worry about chapter 5. Start, reviewing, looking at worksheets for chapters 3 and 4. But let's just do one, and that way on Sunday, we'll be ready to try B. So first things first, I write the half reactions. And what that means is I'm just going to write what's happening to the copper and what's happening to my magnesium. So you'll notice I'm not doing anything, I'm not changing anything, I'm not thinking about electrons. I'm literally just writing the copper reaction and the magnesium reaction. Now, I think it was Abdul Halim who just said, well, when you add the electrons, you have two options. You can add them here or here, meaning you can add them as a reactant or a product. Well, it wouldn't make sense to add my electrons here, because we're never going to get the left and the right side to equal. And as Abdul Halim said, add your electrons to the side with the charge. So I'm going to add 2 electrons to this side because I have 2 positive. And I'm going to add 2 electrons to this side, again, because I have 2 positive. And there's 2 things I want you to notice here, and then halas, we're finished. One is that the number of electrons gained is equal to the number of electrons lost. Do you guys notice that? If you look at each reaction, one reaction is gaining 2 electrons and one reaction is losing 2 electrons. You can kind of think of this like endothermic and exothermic, and like in a way, electrochemistry is the exact same thing as thermochemistry. The only difference is instead of dealing with heat and kilojoules, we're dealing with electrons, but it's the same thing. So a reduction where something gains electrons, so this is my top reaction here would be a reduction. This is like an endothermic reaction. Obviously, instead of gaining heat, it's gaining electrons. An oxidation reaction is when a chemical is losing electrons. This is kind of like your exothermic reaction. And the key here is the law of conservation of energy is still true. If we're gaining 2 electrons from one chemical, we must be losing 2 electrons from another. So do you guys remember, the heat of the system is equal to negative heat of the surroundings? It's the same thing here. If a chemical loses 2 electrons, something else picks up 2. Electrons cannot be created or destroyed. So we're still following our rules or laws of conservation of energy. All right, guys, so that's it from me. Like I mentioned, tomorrow night around, let's say 6:30, I'll send out a link for a tutorial that I will have at 7. So tutorial 7 p.m. tomorrow. Because it's not during class time, I have unlimited time to answer questions, so we can go as long or as short as you want. You might only need 10 minutes, maybe you want an hour, but I can help you tomorrow night. And if you can't make the tutorial, I will post the YouTube video immediately after the class. So by maybe 8 or 9 p.m., there will be a video for you. I'm just realizing something. Actually, sorry guys, I just realized something. I have something happening at 7:45 tomorrow night, so I'm gonna have the tutorial a little bit earlier, at 6:30. Sorry about that. So tutorial tomorrow at 6:30. I have something in my own personal life at 7:45, but we can meet at 6:30, and if you need more time after, that's fine. Okay, so I'll make up. Oops, sorry, I wrote. People are writing me private messages. I don't know why you guys write me private messages. Just send it to the chat, because it's nice for everybody to see the questions. Anyways, so I have a million questions here. Which unit is worth more, 3 or 4? They're equal, 50-50. So they're worth the same amount. Aisha asks if I put Sunday's recording on YouTube. Not yet, but I will this evening. So Sunday and Tuesday today will be online tonight. And copper is being reduced because the charge went down. Exactly. So this was a question from Yasmin. She asked, is copper reduction? Yes. The copper goes from 2 plus to 0, meaning the charge goes down, and it's a reduction. So sorry about the correction on the tutorial. I just remembered I have something at 7:45. So we will meet tomorrow at 6:30, and I will send the link on D2L and email. Okay, so I'll send you guys the email tomorrow. Aisha, I can certainly do that. I was busy this morning. I see a message from you about putting the YouTube video there, no problem, and about some questions from different slides. I'll get back to you in a minute. Thanks, everybody. Have a good day. I'll see you tomorrow night if you are available. Let me know in email if you have any questions. All right, goodbye.